friends. In this video we will be discussing about how to convert a decimal number into a binary number and how we can able to convert a binary number into decimal number, because this particular part can be useful in different sort of operators in different languages. So this is very important part that we need to understand. Okay, so first of all, a decimal to a binary number. So here you can see that we are trying to convert a decimal number 13 into binary. Now what is the binary of it? So here we can see that binary is 1101. So first of all, decimal number means what? There are 10 digits in decimal numbers, like the separate values can be 0, 1, 2, 3 up to 9. So it can be represented as this. This is a decimal representation. But since it is in our routine, we will be writing directly 13 because every one of us are using a decimal number system. So when we write any number, it is by default assumed that it is in decimal number. Now when we talk about a binary number system is formed by using only two digits that can be either 0 or 1. So since there are only two numbers in it, we can say it is binary number system. So very simply, how we can do that? So first of all, what we'll be dividing 13 by 2. So when we divide 13 by 2, so here we'll be getting 6. 6 2s are 12. And the remainder we will be writing here. This is our remainder. Okay. Now again we divide 6 by 2. So that gives me 3 here, and the 3 2s are 6. So remainder is 0. Again I divide 3 by 2. So that is 1 into 2 is 2 and the remainder is 1. And the process is to be repeated until you will get 1 here. So finally, since I reached at this location, now it is the value 1. This is the end of the process. Now this is my binary number. How we can get the binary number? So starting from last digit, we will be moving on upside. We will be moving on upside. So we'll be writing this number like this: 1 1 0 1 1 1 0 1. So this is the equivalent binary number for 13. So I hope you understood. We take another example, like we take the example of 25. So again we divide 25 by 2. So that gives me 12 here. 12 2s are 24. So remainder is 1. Then 6 2s are 12. So remainder is 0. Then 3 2s are 6. So remainder is 0. Then 1 into 2 is 2. Remainder is 1. Since I get 1 here, I will stop. Now what is my binary number? How to get that binary number? So starting from this digit, we will be moving on upside. So that will be 1 1 0 0 1. So this is binary equivalent of 25. So the very simple way to get the decimal into binary. Another way I want to show you that there is another way. So for that, what we can do? Since this binary number system is collection of 0 and 1, only two digits are possible. So what we can do, it is in power. So we can say that we can write 2 power 0, 2 power 1, 2 power 2, 2 power 3. We can write like this. What is 2 power 0? It is 1. What is 2 power 1? It is 2. This is 4. This is 8. Now what you want? You want 13. Okay, you want 13. So choose all those numbers whose summation will be 13. So if I add 8 and 4, that is 12 and 1 that is 13. 8 plus 4 plus 1. So in that location I will be putting 1, 1, 1, 0 and 1. So this will be 8 plus 4 12 plus 1 is 13. So this is another way to get a binary number. Okay. So this is another way to convert our decimal number into binary. So this is how we can able to convert binary decimal to binary. Now next part is we are converting decimal to binary of a negative number. This is very important because in some of the cases we might be working on a negative number. So what we need to do, here we have minus 6. So how I can represent minus 6 in a binary form? So for that, what we need to do? So first of all, write a binary of 6. Very simple, forget about the sign. Write the binary of 6. So what is the binary of 6? But yes, that should be in 8-bit representation. That should be in 8-bit representation. Okay, so actually the binary of 6 is what? 110. How? So 6 divide it by 2. Here it comes 3. So 3 2s are 6. So it is 0. Remainder is 0. Then 1 2s are 2. So here we will be getting remainder 1. So starting from lower to upper, it is 1 1 0. This is the binary of 6. Okay. But that is to be represented in 8-bit. Here it is only 3-bit. So I have written 3-bit and rest 5 bits are considered to be 0. What I need to do afterwards, I need to do the ones complement. Ones complement means what? We need to invert the bits. Wherever it is 0, convert it into 1. So here it is 0, I have converted into 1. Where it is 1, it is to be 0. So likewise, wherever it is 0, we are converting it to 1. Wherever it is 1, we are converting into 0. So this is how I will be getting ones complement of the binary number. Now what we need to do? We need to do 2's complement of the 1's complement. Now what is 2's complement? 2's complement is 1's complement plus 1. So we are going to perform addition operation on binary number. So in binary number, 1 plus 1 gives you 0. 1 plus 1 gives you 0 and carry 1. Here there will be a carry. Carry means the value which is to be forwarded on the next digit. So now it is 1. 1 and 0. So we are 1. We are getting 1. Then remaining bits are same. So ultimately, whatever the value we are getting here is the binary equivalent of minus 6. Okay. So again, simply we have a decimal number minus 6. We are converting that into binary. Forget about the sign. Then what to do? We need to do the ones complement. Ones complement means whatever the digit we have, if it is 0, convert it into 1. If it is 1, convert it into 0. Then what we need to do? We are supposed to perform 2's complement. 2's complement means the value of 1's complement plus 1. Now in binary, when we add 0 plus 0, it gives me 0. No carry. Then 0 plus 1 gives us 1. But 1 plus 1 gives us 0 and carry will be forwarded. What is the carry? Carry will be 1. That is been forwarded. So here 1 plus 1 is 0 and the carry is forwarded here. This is the carry. So 1 plus 0 will be 1. So finally, whatever you will be getting, that is the binary equivalent of minus 6. Okay. Now, next comes the reverse, that how to convert binary to decimal number. So for that, simply here you can see a binary number. Now I need to convert it into decimal. So equivalent decimal is 23. So the fundamental method is this. What we need to do? We need to start from the last bit, rightmost. Here it is mentioned right to left. We need to start from the rightmost. So I have taken 1. that is to be multiplied by power of 2. So initial power of 2 should be 0. Here I have written power of 2, it starts from 0. So 1 into 2 power 0. Then we will be moving from this side to this side. So next digit is 1. So again 1 into power is to be increased, 2 power 1 now. Then again third digit is 1. So 1 into 2 power 2. Then fourth digit is 0, 0 into 2 power 3. And then last digit is 1, 1 into 2 power 4. After that, what we need to do? We need to make the sum of it. So this is 1, 2 power 0 is 1, 1 into 1 is 1, 2 power 1 is 2, 2 into 1 is 2, 2 power 2 is 4, 4 into 1 is 4. Here, since it is 0, the value will be 0, and 2 power 4 is 16, 16 into 1 is 16. So ultimately, sum up this and we will be getting 23. In other words, what we can do? We can write, we know 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 0 is 1, 2, 4, 8 and 16. Okay. Now we have 5-digit number. We will be writing here 1, 0, 1, 1, 1. Wherever it is 1, here, 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 here. Sum of all those numbers. So it is 1 plus 2 is 3, 3 plus 4 is 7 and 7 plus 16 is 23. So this is another way to get the value. So I hope you understood binary to decimal and decimal to binary and binary of a negative decimal number. Okay, I hope you got the idea. If you have any query, you can write to me. Okay, thank you all.